Welcome back, Year 4. In our second lesson today, we're going to look at equivalent fractions again, and we're going to think of a way that we could represent them in a pictorial form, and also how we can think of a rule that's going to help us work out whether a fraction is an equivalent fraction or not, or to make equivalent fractions to a fraction. Okay, so first, a quick recap from yesterday. Fraction rules here, and I want you to find any fractions that are equivalent to the shaded fraction on this wall. This is a pictorial representation, and it can be used to help you. So try, pause now, and have a go. Okay, so hopefully you had a go, and you found that if you drew your line straight down, these were the other fractions you found. 2/8 down here, 3/12, and 4/16. These are all equivalent fractions of 1/4. The problem with a fraction rule like this is if you don't have one in front of you, it can be very hard to replicate it. So is there a way that we can do this slightly easier using the squares we have available to us? So here are two questions. Now, in your squared paper book or something like that, you could draw this using squared paper in order to show how long a bar is. And this is similar to a bar model. And this is where bar models become massively helpful when you're thinking about how to find equivalent fractions. The one thing you have to remember is, in order for them to be equivalent fraction, the whole, the length of the bar, must be the same. If you have your lengths of the bars being different lengths, the equivalent fractions are not going to be right. So when you do this, if you draw your two bars to the same length, evenly split them, then you can find the equivalent fractions between two others. You'll also find whether there is or isn't an equivalent fraction if it doesn't match up exactly. Have a go at these two, and then we'll talk about the answers. Pause now. Okay, so the first thing to do would be on the bar underneath, check you've got your 12 parts. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I know I've got 12. So if I colour in the same amount as the half, which is already coloured in here, and then I count how many we need. We need 1, 2, 3, 4, 5, 6. So our half is equal to 6/12. The same over here, I've got 2/3 coloured in, so there are 3 parts and 2 of them are coloured in. If I colour in the same amount on the bottom bar, which is cut into 12ths, I can then find out how many 12ths are equivalent. I've got 1, 2, 3, 4, 5, 6, 7, 8. So 8/12 equivalent to 2/3. This is a nice representation and can be used in any squared piece of paper, as long as you remember that the length has to be the same and you're splitting it into equal parts. This is a very nice pictorial representation of equivalent fractions. So, thinking about a rule that we can follow, and what you have to do is look at the patterns that you've found before. If you go back to the answers that you've done for the last 2 lessons so far, have a look at the answers and see if there's any pattern you can find and any rule that we can get from it. Have a look now and see what you can come up with. Pause now. Okay, so hopefully you've seen that there is a pattern. It's a relatively easy pattern, and once you know it, you can find equivalent fractions really quickly. So the pattern is that whatever you do to the top of your fraction, you do to the bottom. So if you times the top by 2, the bottom of the fraction, your denominator, is also times by 2. If you were to times your bottom by 4, the denominator times by 4, you would times your numerator, the top, by 4. So a really nice, easy, simple rule to follow is whatever you do to the top, you must do to the bottom. So whatever you times the top by, you times the bottom by, or whatever you times the bottom by, you times the top by. The reason this means that they're the same is because they don't change. You're doing the same thing to both parts, so they must be equal to each other. So let's have a look and see if this works for us. So down here, I've got some different fractions. What we have to do is work out what we've done on the top, and that will give us what's happening on the bottom. So we go from 1 to 2, we've times it by 2, so we must times the bottom by 2. So 4 times 2 equals 8. Now this next jump, 8 times, it's not a nice number to get there. So let's go back to the 4. What do we times 4 by to get to 12? We times it by 3. So 4 times 3 is 12. So that must mean we times this top by 12 as well. So by 3. 1 times 3 is 3. Then we carry on. Now I could go from 3 to 4, but quite complicated. We could go from 1 to 4, which is times by 4, or we could go from the 2 to 4 here. 2 to 4. Let's do that one and see how that gets us. What do we times 2 by to get to 4? It's 2, so we must times the 8 we've got here by 2 as well, and our answer is 16. 4/16 equals to a quarter. Then up here, we've got 100 and 200. Now I can get to 100 because I can do 4 times something equals 100. What do I need to times 4 by to get to 100? This is where your maths comes in, and your times table knowledge links into your fractions. I've said times tables are massively important, and this is why, because they're used all the time in so many aspects of maths. So timesing 4 to get to 100. So 4 times 10 is 40. So I can add another 40 on to get to 80. That's 2 lots of 10 times 4, so that's 10. And then I need another 20. 4 times 5 is 20. That gets me to 100. I've got 2 10s and a 5, which is 25. So I need to times 1 by 25. 1 times 25 is 25. Then we can do the easy step, going from 100 to 200 is timesing it by 2, times the 25 by 2, and that is 50. Our rule works nicely, and it gets us to our answer. Okay, Year 4, here are your questions for this lesson. First off, you've got equivalent fractions, finding them out. On the number 2, you've got 3 ways to make the fractions equivalent, so you can use any way you like. The reason is that they've got missing bits on both of the bottoms or both of the tops, so you can choose what fractions you make, just continue to make them equivalent. You can use any method you like, so you can do the pictorial representation, or you can do the abstract idea using the rule to find the answers. Thank you very much, and we'll see you in the next video.